Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is week 7 of classes. It's our first week back after the Christmas break. So I want to wish everybody a happy new year and hope you had a good break. But now it's time to get back at it. So we've only got 3 weeks of classes left in Term 1B. So if you want to finish your subject that you're working on in Term 1B, you need to make sure that you catch up if you're behind and stay up to date. Excuse me. Make sure you submit your work. Either send it to me or you can give it to your DEC to be sent out. So lots of ways to submit your work. We'll take a look at those in a minute. You can participate in classes in 2 ways, with radio or via Zoom. So the instructions for joining the classes are in your study guide, or you can contact your DEC or contact me if you want to join a class. All PLAR math students are welcome to attend classes, so even if you signed up for PLAR IL, the PLAR math classes are available for all PLAR students. And of course, the classes are recorded, and then the recordings are posted on YouTube, and all PLAR math students can view those recordings. To contact me, you can use email, phone, or send a message on Facebook, whatever way works best for you. The PLAR English classes from Term 1A are still available on YouTube. So you can go to my YouTube channel, B. Osmond Wasa, or you can go to the WASA Distance Education Center channel, where you will find all of the subjects that are being taught in term, throughout the year, I guess, in terms 1A and 1B. So the PLAR math classes are there, and the PLAR English classes are there as well. So the PLAR English classes from Term 1A are there. And if you're working on other PLAR subjects, the science and the history geography are found on that site as well. Or if you go to my page, then you will find the PLAR math and the PLAR English. So whichever site you want to use, it's there for you. Just a reminder that students who did not finish in Term 1A can continue working on the questions in Term 1B, and for those students who do not finish in Term 1B, you can continue working in Term 2A. So PLAR students are not withdrawn until the end of the school year, so no matter when you sign up during the year, once you're in PLAR for the rest of that school year. And you don't have to reapply every term. Just a reminder that this year we have given PLAR students, the option of writing the culminating activity instead of doing the lessons and key questions. So even if you have submitted some of the key questions in the past, you can still opt to do the culminating activity. If you pass the culminating activity, you get the missing credits, missing grade 9 and 10 credits, and you don't have to do the lessons and key questions, and you can just move on to the next subject. If you're not successful with the culminating activity the first time you try it, then you will have to do the lessons and complete the key questions and submit them for marking. And then once you've done that, then you will get another opportunity to write the culminating activity. So it's not, you just get the opportunity once to write the culminating activity. If you fail it, then you do get a second chance to write it after you've done the lessons and the key questions. So if you are doing the lessons, there are 2 types of questions that you will find in the lessons. First of all, we have the support questions, and the support questions are the practice questions that you need to do before you do the key questions. Okay, so as you go through the lesson, there will be some information for you to read, and then there will be a support question. The answers for those support questions can be found at the end of the lesson, right before the key questions. So once you've done the support questions, then go and check your own answers against the answers that are there and see how you're doing. If you're doing well with the support questions, so if you're getting most or all of the support questions correct, then you move on to the key questions. If you are struggling with the support questions, then you need to read the information again, watch the classes on YouTube, or contact me for help. before you do the key questions. Okay, because if you do the key questions, you submit them to me for marking, and you make a lot of mistakes, then I'm just going to send it back to you and tell you to make corrections and redo it. So it's better for you to figure out what you're doing wrong first, and then once you've figured that out, then you can do your key questions correctly, hopefully. Okay, ways to submit your work. So first of all, give it to your DEC, and then your DEC will send it out to us here in Sioux Lookout. If you don't have a learning center, or your learning center is closed because your DEC is away or something like that, then you can submit your own work. So there are a lot of different ways of submitting your own work. So first of all, if you have access to a scanner, you can scan and email your work to studentwork@nnec.on.ca and make sure you CC it to me. Or if you have access to a fax machine, then you can fax to our toll-free number. If you are submitting your own work, be sure to write your name, subject, and your teacher's name on your work, okay? Because you won't have a cover page like you could get at the Learning Center. So you kind of need to make your own cover page. Put your name on it, subject, and your teacher's name. You can put your community on it as well if you want, but make sure that your name is on there. Otherwise, we do not know who is submitting the work. Okay, so always be sure that your name is there. Another way to submit your work is to use your smartphone, and with your smartphone you can either take photos of your work, or you can scan your work, and then you can either email it to that same email address and CC it to me, or you can send it on Facebook Facebook Messenger. Okay, you can also, if you are in Sioux Lookout or you come to Sioux Lookout fairly often, you can use our outdoor mailbox, which is located at the side of the building in the parking lot facing the post office, so between the post office and WASA. It's right there beside the door. You can also use Google Docs to do your work, and then you can send me the link. Make sure the link is shareable and share it with me, and then I can get your work that way. And you can use Google Classroom as well to complete and submit your work. So if you want to go paperless, use Google Classroom. If you do decide to use Google Classroom, please contact me so that I am aware, and I can get you into Google Classroom with all the links and everything that you need. Okay, as I mentioned earlier, only 3 weeks of classes left in Term 1B, and just a reminder that at the end of Term 1B, we will have 2 student draws. One draw will be for students who earned a credit, and one for students who submit work. So for every lesson that you submit, your name will be entered in the draw. So for PLAR students, if you submit all 5 lessons, then you will get 5 chances to win the student work prize, and if you earn the credit, then you will get another chance to win the credit prize as well. Okay, so make sure you get your lessons completed and submitted for marking. Okay, so before Christmas we finished lesson 2, and we actually got started on lesson 3. So of course that means that right now everybody should have submitted all of your work from lessons 1 and 2, and some of the key questions for lesson 3, and we're going to continue on with lesson 3 today. So last class before Christmas we did a makeup class on the Friday, because on Thursday we had our staff breakfast and those types of things. So I ended up having to do a makeup class. So anyway, we talked about exponents, and we talked about the order of operation. So just a review of exponents. So an exponent of a number tells us how many times to multiply the number. So for example, in 8 squared, or 8 to the second power, depending on how you want to read it, the exponent 2 tells us that we need to multiply the 8 2 times. So it's not 8 times 2, it's 8 times 8. It's 8 2 times. And 8 times 8 is 64. So we have exponential form, 8 squared, or 8 to the second power. We have factorization, 8 times 8. So how many times we're multiplying the 8. And then we have standard form, the answer, which is 64. Okay, so exponents are basically a way to write repeated multiplication. So in the exponent 9 to the 6th power, it's easier to write 9 to the 6th power and read it than writing 9 times 9 6 times. So 9 times 9 times 9 times 9 times 9 times 9. We're multiplying the 9 6 times. So that's where the exponent comes in. It tells us how many times to multiply the base. Okay, when working with exponents, there are some rules that we have to follow. And the exponent rules are, first of all, the product of powers. So if we're multiplying powers or multiplying exponents, so here we've got x to the power of m times x to the power of n. So then we add the exponents. So for example, if we have a base of 2 with an exponent of 3 times a base of 2 with an exponent of, say, 2, then what we do is we add the exponents. 3 plus 2, which will give us 2 to the power of 5, 2 to the 5th power. Okay, so this is simplified, an exponent simplified, and then if we're asked to evaluate it, then we would have to multiply our 2 5 times. Okay, because the exponent tells us we're multiplying it 5 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the answer is 32. Okay, so that's the product of powers rule. And then we have the quotient of powers, or the quotient rule, that tells us what to do when we're dividing powers. So here an example, x to the power of m over x to the power of n equals x to the power of m minus n. So when we're dealing with the product rule, we add the exponents. When we're dealing with the quotient rule, we subtract the exponents. So for example, let's use 2 again. 2 to the power of 5 over 2 to the power of 4. So now what we would do is subtract our exponents. So that would be 2 to the power of 5, take away 4, which is 2 to the power of 1. Okay, and this brings us into another rule, that any base with an exponent of 1 is equal to itself. So 2 to the power of 1 equals 2, because there's only one 2. We're not multiplying 2 times 2, because that would be 2 to the second power. It's 2 to the first power, which is 2. Okay, so when we we use the product rule, we add the exponents. When we use the quotient rule, we subtract the exponents. The next rule is the power of a power rule. And with the power of a power rule, we're going to have a power in brackets raised to a power outside the brackets. And in that case, we multiply the exponents. So let's say we have, I'm going to keep using the base of 2, 2 to the power of 2. Inside brackets are 2 squared, and then outside to the power of 3. So now what we would do is we would multiply our exponents. So that would be the same as 2 to the power of 2 times 3, which is 2 to the power of 2 times 3 is 6. Okay, and then we would multiply 2 times 2 times 2 times 2 times 2 times 2, and our answer would be standard form 64. Okay, and then we have the power of a product rule. So this is where we have our numbers or variables inside the brackets with an exponent outside the bracket. And in that case, the exponent goes with each term inside the brackets. So in the example, x, y to the power of m, it's x to the power of m, y to the power of m. So again, this is harder to do with numbers. So if we say we have 2 inside brackets with an m outside the brackets, it's the same thing as 2 to the power of m. Then we have the identity rule, which basically is one I said already. Any base to the power of 1 is equal to itself. So it doesn't matter what the number is. If it's 100 to the power of 1, then our answer is 100. If it's 3,020,000 to the power of 1, then the answer is 3,020,000. Okay, and then we have the zero exponent rule, which tells me that any base to the power of 0 is equal to 1. So it doesn't matter what the number is. The number could be 55 to the power of 0. That is equal to 1. Okay, so basically what you have to do is just remember the rules and then use them. And the more you use them, the better you remember them. So again, practice. Okay, so that was exponents. And now, next thing we looked at was order of operations. So operations, as we talked about, are things like add, subtract, multiply, divide, all of those things that we do with numbers and we do with variables. So sometimes, excuse me, in a math problem, you might have to do more than one operation. So in the example here, 7 plus 6 times 5 squared plus 3, you've got addition, multiplication, exponents, and brackets to deal with. So what do you do first? So you can't just do 7 plus 6, because for starters, the 6 is inside the brackets. So the order of operations tells us that we have to work following a specific order. So that order is B, which is brackets first. So we do whatever is inside the brackets. So if I put this problem down here, 7 plus 6 times 5 squared plus 3. So we do brackets first. So what's inside the brackets? We've got 6 times 5 squared plus 3. So we'll leave that 7 plus for now. And then the next thing in the order of operations is exponents. So we can't really do the brackets because we've got multiplication, we've got exponents, and we've got addition. So we still have to decide what do we do first inside the brackets. So BEDMAS tells us we do the exponents first. So 6 times, and 5 squared is 5 times 5, which is 25. And then I'm just going to bring down that plus 3. So I'm going to rewrite it each time. Now I'm still working on the brackets, so that 7 plus is still just going to come down. And now I do what's inside the brackets. So next is division or multiplication. So, and then you do it from left to right. Here we've only got multiplication, so we don't have to worry about division. So our multiplication is 6 times 25. 6 times 25 is 150, and I bring down that plus 3. So now I've got 7 plus 150 plus 3. So last is addition or subtraction, and we do it left to right. So we've only got addition, but we've still got something inside the bracket, so we still have to work with the brackets first. So 150 plus 3 is 153. And now we've got 7 plus 153, which is 160. Okay, so brackets first, then exponents, then division or multiplication, whichever one comes first, going left to right, and then last is addition and subtraction, again, whichever comes first, left to right. Okay, so here's another one. So let's go through this one. So solve 13 plus 32 minus 5 divided by 2 plus 4 squared. So B tells us we got to do the brackets first. So inside the brackets we've got addition and subtraction. So addition comes first. I'm going to do addition first. 13 plus 32 is 45. Subtract 5, it's still inside the brackets, divided by 2 plus 4 squared. So I still got brackets, so I'm going to do that first. 45 take away 5 is 40. Divided by 2 plus 4 squared. So brackets are done. Next is exponents. So my exponents, 4 squared. So 40 divided by 2 plus 4 squared is 4 times 4, which is 16. Next is division and multiplication. Division comes first, so 40 divided by 2 is 20. plus 16. And then as addition and subtraction, all I have is addition, so 20 plus 16 is 36. Okay, so if I did it everything just going from left to right, I would have a very different answer than what I have here. So you have to make sure that you follow the order of operations to get the correct answer. Okay, so that's what we did before the Christmas break. So today, we've done key question 14, 15. Today we're going to look at polynomials. So we're getting now into algebra. So we'll look at polynomials, and we'll see if we get into monomials today as well. Okay, so beginning on page 14 is some information on polynomials and a little bit about the language of algebra. So some of the terms that you'll be using and you'll be hearing and seeing. So on page 14, then on page 15, the different terms for when we're dealing with polynomials. Page 15, adding monomials and subtracting monomials. So there's some examples there. Page 16, adding and subtracting like terms, and support question 4 is on the bottom of page 17 and page 18, top of page 18. So make sure you do that support question before you do the key question. Okay, so what is a polynomial? So a polynomial is a type of expression. Okay, it's not an equation, it's an expression because it doesn't have an equal sign. So an expression is a mathematical statement without an equal sign or an equal to sign. So it doesn't have an equal sign. 3x squared plus 5. That's an expression. So in this polynomial, there are certain terms that we need to understand. Here, x is known as the variable. So we talked about letters before. So letters are called variables when they occur in math. So x is a variable. 3, which is multiplied by x squared, is the coefficient. So we talked about that before. And 5 is known as the constant. So 5 doesn't change because it doesn't have a variable with it. The power of the variable is of the variable x is 2. So we have again a coefficient, the variable, the exponent, and then the constant. So those are the terms. So the terms of a polynomial are defined as the parts of the expression that are separated by the operators. So remember operations, addition, subtraction, etc. For example, the polynomial expression 2x cubed minus 4x squared plus 7x minus 4 has 4 terms. So 2x cubed is one term. 4x squared, 7x, and 4 are all the different terms that make up that polynomial. So this polynomial is written in standard form, meaning that it's written in descending power of the variable. So the variable with the highest exponent goes first. So this is standard form. So we could write it 7x minus 4 plus 2x cubed minus 4x squared. And it's still correct, but it's not in standard form. So in order for it to be in standard form, the term with the highest exponent goes first, then the next, the one with just the variable, and last is the constant, just the number by itself. Okay, so when we're working with polynomials, we're adding and subtracting polynomials, we have to use like and unlike terms. So like terms is just what it sounds like. Like terms means that those terms which have the same variable and the same power. So the same letter and the same exponent. Okay, so terms that have different variables and different powers are known as unlike terms. For example, 2x and 3x are like terms because they have the same letter. Numbers don't matter, but the letters do. Whereas 3y to the 4th power and 2x cubed are unlike terms because they have different letters, different exponents. Okay, they're unlike. Types of polynomials. Based on the numbers of terms, there are mainly three types of polynomials. So a monomial is a type of polynomial with a single term. So mono means one or single. Okay, so x by itself, negative 5xy and 6y squared are monomials because there's only one term. A binomial is a type of polynomial that has two terms. Bi is a prefix that means two. So you're going to have an operation in here. X plus 5. You get two terms. X is a term and 5 is a term. 3x cubed minus 7. 3x cubed is one term. 7 is a second term. And y squared plus 5. Y squared is one term. 5 is a second term. So they consist of two terms with an operation, addition or subtraction, between them. A trinomial is a type of polynomial that has three terms. Tri means three. So we've got three terms, 3x cubed plus 8x minus 5. So there's 1, 2, there's our three terms. X plus y plus z, x, y, z are our terms. 3x plus y minus 5, 3x, y, and 5 are the three terms there. Okay, so we have monomials, one term, binomials, two terms, and trinomials, three terms. So adding polynomials basically is just a matter of combining the like terms, the terms that have the same letter and the same exponent, with some order of operation consideration thrown in. So we still have to remember to do brackets, exponents, addition, multiplication, division, addition, and subtraction. As long as you're careful with the minus signs and don't confuse addition and multiplication, you should do fine. So you got to really be aware of the minus signs when you're adding and subtracting polynomials. There are a couple of formats for adding and subtracting polynomials. So doing it horizontally, so basically you're putting everything out in one line. So when you do this, okay, you got to look for your like terms. So the first thing you're going to do is clear the brackets. So we're just going to rewrite it as 2x plus 5y plus 3x minus 2y. So we got rid of the brackets. Excuse me. And then group the like terms. So I'm going to just have a different color here. So we got 2x plus 3x. And then we have plus 5y minus 2y. So you notice how I am putting the operation that is in front of the term with the term. That's because when you move it, you have to take the sign with it. So now we're going to rewrite it. So we've got 2x plus 3x and then plus 5y minus 2y. So the sign that's in front has to move with the term. So now I've got my like terms together. I've got my 2x plus my 3x, and I've got my 5y minus my 2y. So my like terms are together. So now I'm just going to add the like terms. So 2x plus 3x will give me 5x. 5y minus 2y will give me 3y. And 5 take away 2 is a positive 3, so there's a plus sign that goes between those two terms. So now I've got 5x plus 3y. Now I have an x term and I have a y term. Because those are unlike terms, I can't do anything else with them. That's it. That's as far as I can go. That's my answer. Okay, 5x plus 3y is my answer. All right, so we can also add and subtract polynomials vertically. So same problem, but we're going to do it vertically, which means that we basically put one on top of the other. So we get rid of the brackets, 2x plus 5y, and then 3x minus 2y. Okay, so now I do my adding and subtraction. So 2x plus 3x is 5x. 5y take away 2y is 3y. So I get the same answer. Okay. Most of the time you will see people who will do it horizontally, but some people find it easier to do it vertically. So whichever way works best for you, that's the way you do it. If it makes more sense to you to put one on top of each other, but you have to make sure you line them up as well. So we'll do a couple of examples to show you that as well. So practice adding and subtracting polynomials. Simplify each expression. Okay, so the first thing we're going to do is get rid of the brackets. So I'm going to rewrite it as 8h squared plus 3h cubed plus 2h cubed plus 4. Okay, so now I want to put my like terms together. Well, here my like terms are already together. 3h cubed plus 2h cubed. The 8 is squared, so we don't do anything with that. So 8h squared. Then I'm going to add 3 plus 2 is 5h cubed plus 4. Okay, so now I have unlike terms. I've got an h squared term, an h cubed term, and just a constant. Can't add any of those together because they're all different. So I'm going to rewrite it in descending order. So that means I'm putting my cubed first, then my square, and then my constant at the end. This is still correct if you write it that way, but even more correct is to put it in, or more accepted, I guess, is to put it in descending order by the exponent. So 5h cubed plus 8h squared plus 4. Okay, so number 2. So we've got 3 brackets here now. Doesn't matter how many brackets you have. So 4b cubed minus 8 plus 2b cubed plus 3 minus b to the 5th power minus 5b to the 5th power minus 7. Okay, so this minus 7 because that's a negative times, just think of the expanding expression. So we've got a negative outside, so when we multiply a negative by a positive, we get a negative. So negative 7, so minus 7. So you got to remember a lot in here. You got to remember the integer rules. You got to remember multiplication rules. You have to remember BEDMAS. So we're getting more complicated as we go along. So now we have to put our like terms together. So let's find them first. So we've got a b cubed, that's it. We've got a constant, and we have b to the 5th power, b to the 5th power. So now we're just going to rewrite everything. So I'll do them in different colors. So we've got 4b to the 3rd power plus 2b to the 3rd power cubed, and then minus 8 plus 3 minus 7, and then minus b to the 5th power minus 5b to the 5th power. Okay, so now I can start combining my like terms. So 4b squared, cubed, sorry, plus 2b cubed. So I'm adding my coefficients. 4 plus 2 is 6b cubed. I can't remember if I said that before. When you're adding and subtracting polynomials, basically you're combining the numbers, the coefficients. And then I've got minus 8, excuse me, plus 3, which will give me minus 5, plus 7, minus 7, which will give me minus 12. And then we've got negative b. Remember, this is the same as negative 1b. So negative 1 take away 5 will give me negative 6b to the 5th power. So now I've got a b to the 3rd power, I've got a constant, and I've got a b to the 5th power. So this is my answer, but I'm going to write it in standard form. So 6b to the 5th power plus 6b to the 3rd power minus 12. So b to the 5th power is bigger than b to the 3rd power, so that one goes first. It's got a negative minus sign in front of it, so that makes it a negative b. 6b cubed is positive, so then I put a plus b, 6b cubed, and then minus 12 at the end. Okay, so got to watch the sign in front of the term. Okay, what's on this page? Let's skip over here. So here we've got 8b plus 2b cubed plus 4b cubed plus 5b. So get rid of the brackets. 8b plus 2b cubed plus 4b cubed plus 5b. Now this might seem like a lot of work, and thinking, why am I doing this? But you're doing it because it's less confusing. So there are my like terms, and I've also got 8b plus 5b are like terms. So I'm going to rewrite it as 2b cubed plus 4b cubed plus 8b plus 5b. Now this one's pretty easy because it's all addition. There's no negatives in there at all, which makes it very easy. If there's negatives or minus signs in there, you have to be very careful. So now add my coefficients. 2 plus 4 is 6. B cubed plus 8 plus 5 is 13b. And that's my answer because now I have unlike terms. I've got a b cubed and a b. Those aren't the same. I can't add them. Okay, let's skip down to number 8. So rewrite 5 minus 9x cubed minus 6 x to the power of 4 plus 3x4 minus 4x squared plus 2 plus x cubed minus 7x squared plus 8. Okay, so now I need to put my like terms together. So let's find them first. So I've got a constant, and a constant. And then I've got a 9x cubed, and there's an x cubed, and then I've got a x to the 4th power, an x to the 4th power, and I've got an x squared and an x squared. So now I'm going to rewrite them, but I'm going to rewrite them with my biggest exponent first. So my biggest exponent is x to the 4th power. So negative 6x4 plus 3x4. So I've done that one and that one. Next is my x3s, which is negative 9x cubed plus x cubed. Oops, that should be a 3. Okay, so I've done that one, and I've done that one. And next is my x squared. So minus 4x squared minus 7x squared. So that one and that one are gone. And then I'm just left with my constants. So plus 5, plus 2, plus 8. Okay, so now I can start combining. So negative 6 plus 3 will give me negative 3x to the 4th power. And then I've got a negative 9 plus, now that's a positive 1, so that will give me minus 8x cubed. And then I've got a negative 4 plus a negative 7, which would be negative 11x squared. And then I've just got my constants, which are 5 plus 2 is 7 plus 8 is 15, so plus 15. So now my answer, because now I have an x4, an x3, an x2, and a constant. These are all now unlike terms, so I can't add any more. I have to leave that as it is. So negative 3x to the 4th power minus 8x cubed minus 8x cubed minus 11x squared plus 15 is my answer. There's a lot of terms there, but that is my answer. I can't do anything else with it. Okay, so again, be very careful, rewrite everything. Make sure that when you rewrite your terms, when you're putting your like terms together, that you take the sign that's in front of the term with the sign when you move it, when you rearrange. Okay, so that brings us to key question 16, bottom of page 25. In part 1, all you're doing is telling if they are like terms or unlike terms. So for example, 15x and 3xy, they are unlike because One has just an x and the other one has an xy. So remember, when you're looking for like or unlike terms, you're looking at the variable, which is the letter, and the exponent, or the power. And the exponent has to have the same number. Has to be the same number. So same variable and the same exponent will give you like terms. For b, ab to the fourth power, 5ab to the fourth power. They have the same letters, ab, and they are the same exponent, so these are like terms. Okay, so that's all you're doing here, is writing like or unlike on the line. Then in part 2, you are actually going to add or subtract the terms in each of the following expressions where possible. So look at them carefully. You may not be able to add or subtract them. Excuse me. If it is not possible to add or subtract because of unlike terms, please write unlike terms. So in A, we've got 13x and 6x. Those are like terms, so we can add them. 13 plus 6 is 19. Don't forget to put in your x. B, we've got 2a squared bc plus 9a squared dc. So we've got an a, bc, a, dc. So these are unlike terms. So what you're going to do is write unlike beside it. Don't just leave it blank. Okay, don't just do nothing there, because then I'm going to look at it and say, okay, this person didn't know what they were doing here. They didn't know how to do this one or whatever. Okay, don't leave it blank. Write the word unlike beside it so that I know that you recognize that you can't do anything with that. Okay, so you've got a few questions to do there. Take your time and make sure you rewrite every time you need to. Don't try to skip steps and don't try to rush through it. Okay, so multiplying monomials. So that is on page 19, and your support question is there as well. Okay, so multiplying monomials. So we already looked what a monomial is. A monomial is a number, a variable, or a product of a number and one or more variables. Multiplying monomials requires that you understand and can apply the laws of exponents. So we did adding and subtracting. When you're multiplying, you just have to remember the exponent laws. Multiplying powers with the same base, you add the exponents. These are the laws of exponents, or the rules. So remember, a cubed times a squared will give you a to the power of 3 plus 2, which is a to the 5th power. Power of a power, you multiply the exponents. So when you have brackets, a cubed in brackets with a exponent of 5, you multiply. 3 times 5 give you 15. Power of a product, find the power of each factor and multiply. So the 2 is outside. That means that we multiply the 2 by 3 and by the a. So 3 times 3 is 9. We're not multiplying by, sorry. The exponent applies to both. So it's the same thing as saying 3 squared times a squared, or 3 squared a squared. So 3 times 3 is 9. A squared is, of course, a squared. Can't do anything else with that. So whatever is outside the bracket applies to each term inside. When you multiply monomials, you will need to perform 2 steps. So first of all, you're going to multiply the coefficients, so that's the numbers. Second, you're going to multiply the variables. And here's where you have to use the laws of exponents. So for example, multiply 2x cubed with 3x squared. So first, multiply the coefficients. 2 times 3, which will give you 6. Next, multiply the variables. But in this case, the powers of both variables will be added as per the rules of exponents. So we've got x cubed times x squared, which is 3 plus 2, so x to the 5th power. So the answer is the number 6. 2 times 3, which is 6, and x cubed times x squared will give you x to the 5th power. So the answer is 6x to the 5th power. Okay, so practice with multiplying monomials. Simplify each expression. Okay, so here we've got 5x squared and we've got a 2 outside. So that means that that's the same as 5 squared times x squared, x to the power of 2 times 2, which is 4. So that's now x4. So 5x squared times x to the 4th power is 5 squared x4. Or sorry, not 5 squared. 5 squared is 5 times 5, which is 25. So the answer is 25 x to the 4th power. Okay, the next one we've got negative 9x times 6x squared. So we're going to multiply the numbers. Negative 9 times 6. Negative 9 times 6 would give me negative 54. And then we're going to do x times x squared. So that's x to the power of 1, which means we add the exponents. So that will give us x. 2 plus 1 is 3. So negative 54x cubed. Number 3, we've got y cubed times y to the 5th power. So this is basically using your exponent rule. So y, 3 plus 5 is 8. Y to the 8th power. I can't do anything else with that because it's a variable. Then we have z times negative 6z cubed. So remember that's 1z. So 1 times negative 6 is negative 6. Z, that's z to the power of 1 times z to the power of 3 is z to the power of 4. Number 5, 9z times 4z. So multiply our numbers. So we've got negative 9, that's 1. So that's still going to give us negative 9. Z to the power of 1 times z to the power of 4 is z to the power of 5. Now in the next one we've got 5x squared y to the 5th power inside brackets, and then that's all to the power of 2. So now we've got to take the 2 and apply it to every term inside the brackets. So that's 5 squared x 2 plus 2, 2 times 2 is 4, y 5 times 2 is 10 times 9x squared. So now we've got 5 times 5, which is 25, x to the 4th power, y to the 10th power, times 9x squared. Okay, so we're going to multiply our numbers. 25 times 9 is 175. No, it's not 175. It's 225. Okay, so equals 225. I might not be able to fit all this in here. And x squared, or sorry, x to the 4th power times x squared. So I'm just going to put it down here so you can see what I'm doing. Times x squared equals x. And then we're adding the exponents to the 6th power. And we're lost. Y to the 10th power times x squared. Well, you can't change those anyway, so let's write our answer down below here. So what is it? 225 x to the 6th power, y to the 10th power. Okay, so you got to multiply your numbers together, and you got to multiply your variables. So remember, if there's an exponent outside the brackets, it applies to every term inside the bracket. So you're going to multiply that out first, and then if you have to multiply by another term, like here, then you multiply that second. Okay, so take your time. Okay, so that brings us to key question 17, the bottom of page 27. Multiply the following. So you're going to multiply those monomials. Take your time. Remember, number times number, variable times variable, using the exponent rules. So if it's an x by itself, that's x to the 1st power. Okay, so again, take your time. Okay, so that is it for our class today. So what's today? Tuesday. So on Thursday, we will finish up lesson 3, and we will also get started on lesson 4.